So you stand at the top of a soapbox derby hill, and you look downwards. Save that. So you're up here on the top of the hill. The angle of depression is the angle between your line of sight and the line drawn horizontally. Now, I should have a little person up here, and the angle of depression should be from their eyes straight down, but we'll just do it straight from the top of the hill. So the angle of depression is you go straight out and you look downwards. So it's this angle right here. So that angle of depression is 13 degrees. So this is the angle of depression. Yeah, and the vertical drop is 50 feet. So the vertical drop is straight down. So that's 50 feet. Okay, so Isabella, you were right. What were you saying that you were trying to do? Yeah, this is a right angle up here. So if this one's 13 degrees, you can find the angle right here, which is 77 degrees. Good. Okay. It says, find the distance D that a soapbox would travel on this hill. So where's D? Is it on the bottom of the triangle? Is it the hypotenuse? It is. It's the hypotenuse, right? Okay, so if I'm doing this, I'm looking at the angle that I have, which is right here, 77. And I'm talking about how these segments are related to it. So is it the adjacent? Is it the hypotenuse? Is it opposite? What is it? Yep, so we have the adjacent angle, and we have the hypotenuse. So if you spell out SOHCAHTOA, you want the one that has adjacent and hypotenuse. So cosine. So we have cosine of our angle, 77 degrees, equals adjacent, 50, over hypotenuse, D. Okay, and we're going to solve it out. So cosine of 77, we get 0.22495 equals 50 over D. Now remember, we're not just dividing the 50 over. You need to think about cross multiplying. You need to multiply your D to the left side. So I get 0.22495D equals 50. So what you're really dividing by is the 0.22495, right? So you're going to do D equals 50 divided by 0.22495. So I'm going to do 50 divided by answer on my calculator, so it's nice and precise. So when I do that, I get 222.271. So about 222 feet. Dana, do you have a question? Are you raising your hand? Yeah. Yep, oh, you can do this a couple different ways. Someone in the first class was saying they used the triangle that was over here. So they used 13 degrees and they put 50 right here. And they could find D that way. Is that what you did, Dana? Okay, what you could also do is they knew, this is really good if you guys remember this. Do you guys remember from geometry? Yeah. If you have parallel lines, so these are parallel lines here, and you have this transversal, based on that, if you have 13 degrees also has to be here. Oh, yeah. So they did it with 13 degrees. So it's up to you. Okay, to solve a right triangle, you need to determine all the 6 parts of the triangle. So you need to know all the sides and all of the angles. So you can solve a triangle if you know 2 side lengths, or if you know 1 side length and 1 acute angle. So not the right angle. All right, so let's say I want to solve for the angle. So if sine of some angle equals a value x, then, do you guys remember what you used to solve for a? To get a by itself? I heard someone say it. How do you get rid of your sine? What's the opposite of sine? Oh, negative. Inverse sine, right? It's like that weird. Don't you like mix the letters? ST, stand. So you're solving for the angle, so you do inverse sine of x. All right, if I'm solving for cosine, or if I'm solving for the angle with cosine, I would do inverse cosine of x equals a. Or sorry, y equals a.
Yo, Ms. Cox, do you know what I'm talking about when they switch the letters up of the SOHCAHTOA?
No, I don't think so.
You know
Oh, secant, cosecant?
Yes.
Yes. I do know what you're talking about. Okay. So let's see how those are used. So use a calculator to find each of the following. So I'm trying to solve for the angle measure. So A, C, B, and A are all angles. So if I want to get rid of my sine, a lot of my students like to write inverse sine out front. kind of like you did with matrices. Do you guys remember with matrices you wrote inverse of A out front? Okay, when you do that, those are going to cancel. They're gone. So we really just have A left. Okay, you don't have to do that step if you know how to switch it. That's fine. So when you do that inverse sine of 0.9205, you get 66.999. We went to the nearest tenth. So we get 67.0 degrees. Now I'm sure Mr. Sire could want you to be very precise and do measure of angle A, but I don't really care, so you guys can just have A. You're past geometry. All right, cosine of B. So if I'm solving for B, I need to do inverse cosine. So I'm going to do inverse cosine of 0.1392. Anybody have that one? Yep, 82.0, right. Yep. Okay, so someone do 3 and someone do 4. So how about Lisa, you do 3, and Logan, you do 4. So Lisa, what'd you get for number 3? Yeah, can you guys tell I looked these up off a chart, so they're all nice and even. All right, and then the last one? 15.0. Did you guys get all those?
Yes, ma'am.
Alrighty. So our calculators are working properly. So let's try to actually solve a right triangle. So let's go on to the next problem. Okay, so solve the right triangle, round decimals to the nearest tenth. Okay, so this is a case where I have 2 side lengths. So based on this, I should be able to find every single angle. So first things first, let's label. Across from angle C, we write C, little c. Across from angle B, I write lowercase b. Across from angle A, I write lowercase a. So those are the sides I'm trying to find.
When you say solve the triangle, what does that mean?
It says, it means find everything you can possibly find, all the angles, all the sides.
Okay.
Okay, so little a, that's easy to find. How can I find little a? Pythagorean theorem, right? A squared plus b squared equals c squared. And I think Young saw that it's going to be 6 because this is kind of a 3, 4, 5 right triangle. Do you guys see that? Yeah, this would be the 4, this would be the 3, this would be the 5, right? 6, 8, 10. It's in that same ratio. All right, so a squared plus 10 squared, 8 squared. Did I write something? Yeah, this is confusing, isn't it? Let me not write a squared plus b squared equals c squared, but you see why it's confusing to write it that way. So I'm going to say a squared plus 8 squared equals 10 squared. So a squared plus 64 equals 100. Subtract out your 64, so I get 36. So my little a is 6. Okay, so we're good with that one. We got 6. So we have all the side lengths. Now we need to find some angles.
Because if you do
90 degrees?
inverse.
Yeah, we're going to need to do inverse something. Okay, use something that you've already found, guys. So you probably want to, or not that you've already found, use the things you were given originally. So we were given B and C originally. You don't want to use something that you found because what if you were wrong with that? So let's try to use these as much as possible. So any angle, so let's say I'm trying to find angle A. Based on angle A, 10 would be hypotenuse, 8 would be adjacent. So what do I need to use to find angle A? I need to do cosine, adjacent, and hypotenuse. So cosine of angle A is adjacent, which is 8, over hypotenuse, which is 10. So that's adjacent, this is hypotenuse. So I have cosine of angle A equals 0.8. I need to get rid of my cosine, I need to solve for A, right? So I'm going to do inverse cosine. So second cosine on your calculator, 0.8. So when I do that, I get 36.869, yeah, so 87. I'm not rounding very well. So 8, 7, we'll say that. Okay, that's what A is. Oh, I said round to the nearest tenth, so 36.9, right? All right, so this is the angle right in here, 36.9 degrees. So how do I find angle C? Not plus 90. And then subtract from 180, right? So you could add 36.9 plus 90 and subtract them from 180 to get this. But I mean, if I know that's 90, I'm just going to say these two angles have to add up to be 90, right? So I'm just going to say angle C plus 36.9 equals 90 degrees. So 90 minus 36.9, too complicated? I get C equals 53.1 degrees. Okay. We have now solved the triangle. We have everything. All right, you guys try the next one. So solve the right triangle, round decimals to the nearest tenth. All right, so the first thing is real easy. So how do you guys find the other angle? 180 minus 90, so that would be 90, minus 65, so you get 25. So angle Z is easy. All right, so X we know, or not X, we know Y, little y. We need to find X. We need to find little z. Okay, so let's use the angle we were given originally, 65. We need to use hypotenuse somehow. If I'm finding x, that's opposite. So I need to find opposite and hypotenuse. So sine, right? So I have sine of 65 degrees equals opposite, so x, over hypotenuse, so 20. So x is going to be whatever 20 times sine of 65 is. Did anybody get that one? 80? 18.12, so 18.1, good. Okay, so we have that. Now you can always do Pythagorean theorem to find the other one. It doesn't matter. I think it's just as easy as doing another trig ratio. So if I'm using angle 65 and I want to find z, that's adjacent, and I want to use hypotenuse again. So I'm going to do cosine of 65 degrees equals adjacent, which is z over hypotenuse, so 20. So multiply your 20 over, you get 20 cosine of 65 equals z. 8.4 or 8.5? Okay, so 8.5. Okay, you've now found the three things you need to find. All right, let's skip the next one. So you guys can do it if you want, but we'll skip it. I think you're understanding it. Oh, I don't have it there. So we need to do the one with Haley and L. Okay, so it says, during a hot air balloon flight, Elle and Haley look upwards and see the balloon as shown in the diagram below. The angle of elevation from L is 28 degrees. So let's kind of fill in as we go. So looking upwards, the angle from her to the balloon is 28 degrees. So right here. And she is 1.8 miles from the spot on the ground directly below the balloon. What is the height of the balloon? So we're trying to find h. Okay, so based on our angle, what do we have? Adjacent and? Nope. Opposite. So what uses adjacent and opposite? Yeah, we need tangent. Oh, they're here for the story problem about them.
This is your problem. Oh my gosh, Ella, we're famous.
All right, so we do the tangent of 28 degrees equals opposite, so h over adjacent, so 1.8. So h is whatever tangent of 28 is times 1.8. Anybody get that? 0.956, okay. That's in miles. Okay, that's how high the balloon is. Okay, keep that in your calculator. All right, we're going to use it. So it says Haley is 2.8 miles from Elle. They're so far away from each other. All right, so what does that mean the distance from Haley and directly below the balloon is? 1.0, right? All right, find the angle of elevation from Haley. So we need to find angle H. We know the height, little h, we just found it. So we're going to use that. So we're going to use 1 and the little h. So related to my angle, I have opposite and adjacent. So I need to do tangent of h equals opposite, which was what we just found, 0.957, divided by 1.0. Well, that's nice. That's just 0.957 still. So how do I solve for capital H? Yeah, inverse tangent of the answer you just found. What do you guys get for the angle?
43.7.
40 what?
43.74.
Okay, 43.7 degrees. Good. All right, we feeling pretty good about SOHCAHTOA?
Yeah.
All right.